I need to make an addendum to the work we did in the week 3 Q&A. As I got into IXL, I noticed that they did ask you to write your answers in simplified, rationalized form and not to round. So that kind of just throws out the window some of the work that we did when finding a side given an angle and another side, an angle not the 90-degree angle. You can still use your needs and knows chart, no problem at all. And so I just need to show you what to do so that you can get your answer in simplified, rationalized form. It's really no more difficult. You'll just do some multiplication instead of finding your sine, cosine, or tangent. You will need your printout of your unit circle, and then you'll fill in the values just as before. So let's just say here is a problem like you would see on IXL. So they're giving you this right triangle and you want to find the unknown side. So in this case, they're asking you to find ST. So ST is from here to here. You're given theta of 30 degrees. So the side that you need to find is the opposite side. So my need here is opposite. So need is opposite. My know is hypotenuse. So if I go to that NAC chart, that's the acronym for needs and knows, the one that uses opposite and hypotenuse, your equation there, it gives you opposite equals, and I don't have the image here for that, but you should have that printed out. The image or the equation here is opposite equals sine theta times hypotenuse, okay? So let me show you how to do that. The thing that's going to change here, instead of using sine 30 degrees and then plugging that in your calculator, times hypotenuse, which is square root 39, you're going to use the actual coordinate of sine theta from your unit circle. So you're not going to plug sine theta into your calculator. You're going to go to your unit circle and you're going to find the coordinate of sine theta. So if you take a look over here, you want to find the angle of 30 degrees, which is right here. So you're looking at this set of ordered pairs. Now recall that when you have this set of ordered pairs, you have x comma y, and your x is your cosine and your y is your sine, always, okay? So that's always the way that that's going to work. So when you want to plug that into your equation, let me get some room here. Let me make this a little smaller. Okay, so our sine at 30 degrees here is 1/2. So since we know that the sine at 30 degrees is 1/2, instead of writing sine 30 here in this equation like we used to, and then using our calculator, we're going to replace sine 30. We're just going to get rid of that and we're just going to write the value 1/2. And that's what we're going to use in our multiplication. So now we're going to multiply that times 4 square root 39, and that's over 1. So now we just have a basic fraction multiplication problem. So we have 1 times 4 square root 39, which gives us 4 square root 39 over 2. And that can be simplified. We can cross out here. 2 goes into 4, and you're going to get 2 times the square root 39 over 1, and of course we don't need to write the 1, okay? So let's just maybe take a look at another example. Let's see, let's get a blank page here, and I'll draw a right triangle for us to look at. Let's use a different angle. Let's say we have a right triangle. And here's our hypotenuse. Let's say this is T. And let's say this is R. And our angle is 45, and here's S. And let's say we want to know this side right here, and let's say we know our hypotenuse is 2 square root 23. Okay, and there we go. Oh, look, there's my phone ringing. Okay, so if we do this, we're looking for, we need and know. So our need is going to be opposite. Our know is going to be hypotenuse. If I can spell. Good grief. Let me erase that. What a mess. Hypotenuse. There we go. HYP. All right, so we need opposite. We know hypotenuse. So it's going to be the same formula again, but what's going to change is the angle that we have. So we're still going to use sine theta equals opposite over hypotenuse. So our need and know tells us that when we want to do that, we want to multiply sine theta times hypotenuse in order to get the opposite side. All right, so what we need to do is replace this value with the actual coordinate of sine theta. So let me grab the unit circle so we can look at that again. All right, so here's the unit circle. We've got that. So since we're working with 45 degrees, we're going to look for sine of 45 degrees, and we're going to see what that value is. So let's get sine 45. So let's find the 45 degree angle and find those coordinates. So here's our 45, and here are the coordinates that go with that. Now just to remind you, we've got x comma y in an ordered pair, and it's cosine sine. Okay, so this one's going to be your sine value. Your second one's going to be your sine value. So now instead of writing sine 45, let me get a different color. I don't think we can see that one very well. Instead of writing sine, we're going to write square root 2 over 2 because that's the value that's there. We're just giving it to us. No magic thing happening. We're just gonna do that. We're going to multiply times 2 square root 23 because our formula tells us it's sine theta times hypotenuse, and that's over 1. And then we're just going to multiply, and we're going to see what we're going to get. So we're going to get 2 times the square root of 46 over 2, and our 2's are going to cancel. And let's see, we're going to get square root 46. Now, IXL wants that in simplified form if you can. You can use that handy dandy simplification tool at Math Warehouse that we talked about during our Q&A session, or you can do trial and error and see if you can simplify this. I'll go ahead and tell you that square root 46 can't be simplified further. So that's the simplest form that you could put that radical in. So if you were to put square root 46 into IXL like that, then that is how it would look. So that's how you would do it in rationalized form instead of the decimal form like we did on Q&A. So sorry I didn't realize that that's how it was going to make you do it, but actually I think this may even be a little simpler. I don't know, but it's not too much trouble, too much of a change, but I want to make sure you knew before you sat down and tried to do it. I didn't want you to get frustrated.